Now we are going to discuss about the de Broglie wavelength of an electron in an accelerating potential capital V. So this is the basic equation, lambda is equal to h by p. Now we are considering a single electron. Suppose this electron in an accelerating potential difference. That is, we are providing a potential difference V. It is a positive electrode and it is a negative electrode. We have an electron in between these electrodes. What will happen? Since electron is of negative charge, it will move towards this electrode. Like so, electron is moving towards the positive electrode, so that a wave is moving towards this positive electrode, because according to de Broglie hypothesis, electron moving means we can associate a wave with this electron, right? So that we have to find the wavelength of that electron, that is the wavelength of an electron in an accelerating potential difference capital V. So V is the potential difference we are applying. We can apply any potential difference, just like 5 volt, 3 volt, 100 volt, etc. Okay, now we are going to find the de Broglie wavelength of this electron. So we have the basic equation, energy is equal to EV. It's a basic equation. How to find the energy of this electron? It is given by E into capital V, where E is the charge of the electron, that is 1.6 into 10 raised to minus 19 coulomb, and capital V is the applied potential difference. So from E and V, energy can be written as E is equal to EV. This is first equation number 1. Okay. Now we have the basic equation. Kinetic energy is given by E is equal to half mv square. So these two equations are for energy, so that we can equate these two equations. Half mv square is equal to EV. Okay. From this, V square can be written as 2 EV by m, or V is equal to root of 2 EV by m. So equation for velocity. So small letter V is the velocity and capital V is the applied potential difference. So from this equation, velocity can be calculated. Now what is momentum? Momentum is equal to mass into velocity. So instead of V, we can substitute this root of 2 EV by m. Okay. So m into root of 2 EV by m. Now this m square can be taken inside the square root, so that it will become m square. Sorry, m can be taken inside this root, so that it will become m square, right? So P is equal to root of m square 2 EV by m, and 1 m can be cancelled, therefore P is equal to root of 2m EV. So it is the equation for momentum. Now how to find the wavelength? Lambda is equal to h by p. Just substitute this momentum here. So lambda is equal to h by root of 2m EV, where h is the Planck's constant, m is the mass of the particle, E is the charge of the particle, and capital V is the applied potential difference. So it is the equation to find the de Broglie wavelength of electron. Lambda is equal to h by root of 2m EV.